Everybody's sick, huh? Except maybe Matt. You're the only one who doesn't look sick today. You're sick. You're sick. You're sick. I'm sick. Everyone's sick. Okay, just one more minute and then we'll have a look at the homework from last time. Sorry, that's me tapping. Just one more minute and then we'll have a look at the homework if you want the electric fields. Okay, shall we have a look at the homework? Did you get question 1 finished? Huh? How many? Oh, nearly finished. Okay. Well, can we look at the homework now? So, the first one. If the charge on a particle is doubled, then what happens to the force on the particle in the electric field? So you have E equals F over Q. Okay? So, what happens is you replace the F with 2F. So what would happen to the E? Would it be bigger or smaller?
Double.
Yeah, it'd be twice as big. Double, correct. Alright. I hope that was okay. Right, next. A 1 microgram particle of charge 1 millicoulomb is attracted towards the center of an electric field. The field caused the particle to accelerate from rest over a distance of 1 centimeter in 1 second. How strong is the electric field? Okay, so you know the formula E equals F over Q. We don't know F. We can say F is MA over Q. Now what do we know? Do we know the M? We do. Do we know the Q? We do. But we need to work out the A. What do we know? We have U is 0, V we don't know, A we don't know, T is 1, and S is 0.01. So what formula would give us A here? S equals UT, I think? You could have S equals UT plus a half AT squared. So that's 0.01 equals a half A, and T is 1. So A is just 0.02. So this is M. M is 1 microgram times A, which is 0.02, over Q, which is 10 to the minus 3. So that's 0.02 times 10 to the minus 6. multiply, 1, 2, divide, 6, 7, 8, 9, 20 times 10 to the minus 9 newtons per coulomb. Or in other words, 20 nanonewtons per coulomb. Did you have trouble with that one? What's that, Siva? What went wrong for you here? Which part? Oh, sorry, I should turn the light off. What did you get for acceleration? We're good? Oh dear. Yeah, man. Siva, we can go on to the next one. And that's... Yeah. Okay, number 3. Number 3. A 2 milligram dust particle falls from one copper plate to a lower copper plate, a distance of 10 centimeters. And it took 10 seconds to do this. And it's 2 milligrams, so that's 2 times 10 to the minus 6 kilograms. And it falls down. And the charge was minus 200 E. Now, I didn't say this in the question, but the top plate is negative and the bottom is positive because I need this to fall down. So I need it to be like, well, oh no, sorry, I'm so sorry. It has to be this way. Why? Imagine you have 10 centimeters, so that's about this big, okay? If I just drop something, how long would it take to fall? Not long, maybe like less than a second. How long did it take this particle to fall? 10 seconds. So what must be happening is that the top plate is positive, the bottom one is negative, and this particle is negative. So what's happening is there's a force trying to pull it back up to the plate, up to the top, but it's not strong enough to cancel the weight. So the only effect is to just make it fall a little slower. Yeah? Do you get the idea? Yeah. So what do I ask you for? The E. So E equals F over Q, which equals MA over Q, which equals 200E. I won't worry about the minus because I'll figure it out in a second what the sign should be. I'll just make everything positive to keep it easy. So the U is 0, the V we don't know, the A we don't know, the T is 10 and the S is 0.1. And I'll just take down as positive this time to keep everything simpler. Down as positive. So we have to work out the A. So I could do the same trick. I could say S equals UT plus a half A T squared, which is 100. So that's 50. So that's 0.1. So the A is 0.1 over 50. Which is 1 over 500. So what I'll do is I'll take the A out here and put in 1 over 500. And I'll put in the E as well. What's the E? 1.602 times 10 to the minus 19, isn't it? Yeah? Okay, so if we bash that into the calculator, we'll get our E. What do you get for this, Siba? Yeah, should be, I think.
1, 2, 4, 8, 4, 3, 9, 4, 5.
945. That is big. How big is that? 1, 2, 3, 4, 5, 6. That's like 125 mega newtons per coulomb. Did you get that big, Matt? I think it should be pretty big. What did you get? What did you get, Andek?
3.12
Yeah?
to the 10 to the about the
Oh, what did you get, Matt?
6.24 10 to the power
Why can't you all get the same answer?
8.
Okay, now the problem is I'll have to do it to see what it is. We'll see which one of you is right. Maybe none of you. Come on. So slow. There we go. Alright, let's see who is right. 2 times 10 to the power of 6, 200 times 1.602 times 10 to the power of minus 19 times 500, and the winner is... Not me! Not me! Let's try that again. And the winner is... Siba! Congratulations. 125 meganewtons per coulomb. Seems like you're the most trustworthy with the calculator. What happened, Matt? What did you type in wrong? No, okay. Continue. Next one. Number 4. This is our last calculation. The next one's just a graph. One electron orbits one proton. So there's the electron, and around the proton it goes. And the radius here is 10 to the minus 10. And the electric field strength is 1.4 times 10 to the minus 10 newtons per coulomb. Ah, did anybody get this one? What is the periodic time? Did anybody get this?
1.6 times 10 to the power of
Negative 10. Could be, yeah, could be. Let's calculate it. So look, this is moving in a circle. Yeah? So the formula, do you remember, for circular motion, the t equals 2 pi over omega. Do we know omega? No. We could work it out. Because you know for circular motion, F equals m omega squared or. Yeah? And also we know that F equals EQ. So together, that means EQ equals m omega squared or, which means omega is equal to EQ over m or square root. So that means T is equal to 2 pi root m or over EQ. Now, we know 2, we know pi, we know the mass of the electron, we know the radius of the orbit, We were given the electric field strength and we know the charge of an electron. So we can now work out the periodic time. I'll give you a minute to write it down before I type it in. Yeah? So let's type this in. Oh, sorry, can I type it in now, or do you need to write it down?
Yeah.
Type it in? Seba, can I type it in? Yeah? Okay, so you might need to give me the info as I type. It's 2 pi root fraction. Okay. Now, my calculator has the mass of an electron stored as constant number 3, I think. Yeah, it does. But you can type it in because I gave it to you. The radius is 10 to the power of minus 10. The electric field is 1.4 times 10 to the power of minus 10. And the charge is E, which I think is constant number 23 on my calculator. Yeah. So the time is... Oh, sorry, Matt, you didn't get it. I'm going to write this as microseconds. It's 12.66 microseconds. Microseconds. So that's 12.7 microseconds. Yeah. Continue. Matt, maybe you want to buy a new calculator. I don't know if that calculator's working for you. What do you think?
I think it's working.
Okay, as you wish. As you wish. Can I scroll down? Yep. Okay. Right, number 5. Shown below is an electric field around a large positive charge. Sketch a graph of what you think the electric field strength against the radial distance may look like. So might be easier now that we've done this class. So there's the ore, and that's measured in meters, and there's the electric field strength, and that's measured in newtons per coulomb. What do you think happens to the electric field strength if we increase the radius? Decreases. Because the further away you are from the charge, the less strong the field is. So I think the graph would look something like this, a decreasing graph. Now you actually know this from the new formula. You have the formula E equals 1 over 4 pi epsilon 0 Q over R squared. So can you see, as the R squared gets bigger, then the E must get smaller. You got that? Wait. So look, just take the last 5 minutes just to finish question 1. What part did you say you were on, Seba? F, was it? So if you can get question 1 finished today, that'd be great. That leaves you with 2 and 3 to do for homework. 2, 3 and 4, I mean. So, can I close this, Andak? Yeah. Can you try and finish question 1? Matt, which part are you on in question 1? Okay, try and finish question 1 and then you can go. I can close this?